Hi, this is Mr. Ward, and I'm going to do a couple of short videos about how to do word problems with linear equations. You might have noticed that in here I created a little flow chart for you. You might have to zoom in a little bit to make sense of it, but let's go ahead and zoom in just a little bit, and let's see what we can do with it. So I have created a couple of word problems. Now, you might notice already they're under slope-intercept form, so they probably work best with slope-intercept form. But let's actually think about it. So here's the story. You've spent $9,000 to rent the arena for your monster truck rally, and you're going to charge $27 per ticket. How many tickets will you have to sell to make a profit of $4,000? Okay, so you want to start off by just looking at the scenario. Don't look at what you're having to solve yet. Let's just look at the scenario. We need to come up with an equation in order to solve this question. So let's figure out what equation type would work best. So you've spent $9,000 to rent your arena for the monster truck rally, and you're going to charge $27 per ticket. So if I go here to my flow chart, and okay, we start off with the question, is there anything like a rate in the story? In fact, yes, there is. There's $27 per ticket. Okay, so we follow yes. Are there two rates? Well, no, there's not. There's just the one rate of $27 per ticket. Okay, so we go, no, there is one rate. Okay, so if there were two rates, we'd try standard form. So we're not going to try standard form probably. There is one rate. Okay, so there is. So yes, now there's the next question. Is there a Y-intercept? So if there's a Y-intercept, we can actually how to move this around so we can see what I'm doing. Since I've zoomed in, it moves too fast. So is there a Y-intercept? Well, a Y-intercept would be represented by when zero things have happened, when like it'd be a starting point. And there is a kind of starting point in our story. Let's find that starting point. That starting point is when you spent $9,000 to rent the arena. So we actually have a Y-intercept, which is 9,000, and we have a rate of $27. So we can set up an equation of Y equals the rate of 27x. And the $9,000 is negative. That's money you spent. So that's that. So you won't see this on this graph very well. We have to zoom out a bit before we see it. Okay. And there's our equation. Let's go way down here. $9,000. That's our Y-intercept. And it's got a very steep slope because it's up $27 every time one ticket is bought. Okay, now we have an equation. How do we use it to solve this question? How many tickets are you going to have to sell to make a profit of $4,000? Well, Y, it turns out, is the output. It's the amount of money you have made. It is your profit because it is the number of tickets sold, that's X, times the price per ticket minus what you already spent. So we can take this equation and we can figure out what X would be if Y was positive $4,000. Okay, so $4,000 is how much you want to make, and you need to know how many tickets at $27 would you need to sell to offset this $9,000. So we can start solving that. We use our basic equation solving tools, add 9,000 to both sides. We get 13,000 equals 27x. Oops, that's a 27x. Okay, and you can see this green line, this vertical line, that's actually telling us what we need. And it intersects with 4,000. So in Desmos, it actually works it out for you. And now we just say, okay, divide both sides. We've got 13,000 equals 27x. We divide both sides by 27x. So x will equal 13,000 divided by 27. And that's how many tickets you would need to sell. Of course, being tickets, you can't sell fractions of a ticket. So you're going to need to sell, you have to round up to get the actual answer for this question. So the answer ends up being 482 tickets. And we can test that out. we can say y. So we can say 27 times 482 minus 9,000, and that gets us a profit of $4,014. So that's the winning number of tickets that we need. Okay, let's take a look at the second question. My desk is 36 inches high. I have a stack of 2/5 inch thick notebooks on the table. How many of these would I need on my desk? Would need to have on my desk to reach the ceiling, which is 142 inches above the floor. Okay, so once again, let's look at our flow chart here. Okay, is there a rate in the story? Is there anything like a rate? Well, there's an amount of inches per notebook. So yes, there is. Are there two rates? Not really. There's just one. So there's one rate. Yes, there is one rate. That's the 2/5 of an inch per notebook. Is there a Y-intercept? Well, there is a starting point. The starting point is the top of my desk, 36 inches high. So there's a Y-intercept at 0.36 and a rate of 2/5. So we can set up an equation with this. We say y equals 2/5 for the slope, x, and then we would add 36. I'm going to zoom in a bit and then zoom out again. So now we have our equation. And we're not going to have negative numbers in notebooks, but we could, of course, restrict the domain if we wanted to. But I'm not going to worry about that right now. What we really want to figure out is how many notebooks, and X is the notebooks, would it take for Y, the stack, to reach the ceiling. So this is the height, the overall stack of my desk. Oops, that should be 36. 36. My desk to reach the ceiling. So 2/5 times each notebook plus 36. If there's no notebooks on my desk, then it's just a 36-inch stack. We want that stack to be 142 inches, so we replace y with 142 equals 2/5 x plus 36, and then we just solve for what x is. So subtract 36 from both sides, so 142 minus 36 is 106. Okay, equals 2/5 x, and then you can use the trick of multiplying both sides by the reciprocal of 2/5. So 5/2 times 2/5, and 5/2, 5/2 times 106. So the 5/2 times 2/5 goes away. That's just 1. So now x equals 5/2 of 106. So what is 5/2 times 106? It's 265. So I need 265 notebooks to reach the ceiling. Okay, and in fact, if we zoom out, we'll see a vertical line at 265 that intersects with our line. 265 notebooks stacked on my desk will reach the ceiling at 142 inches off the floor. Okay, I'm going to stop on that one. Just want to emphasize the key idea for slope-intercept form equations. You're going to have some output equals a rate times some input x plus a starting point, which will be the y-intercept. And if you have those pieces, you can put together a slope-intercept form equation. And then if you have one of the values that you either have x or y, so here this 4,000 is y, you can figure out what x is by just using your basic equation solving tools.